In our previous lesson, we saw how we can work with two-dimensional arrays using pointers. Now in this lesson we will see how we can work with arrays of further higher dimensions like three-dimensional arrays using pointers. We will also see how we can pass multi-dimensional arrays as arguments to functions, because that's one scenario where pointers once again will come into picture. I will start with a quick recap of what we have discussed in our previous lesson. Whenever we create a multi-dimensional array, and let's pick up the example of two-dimensional array that we had created in our previous lesson, we must think of the multi-dimensional array as array of arrays. Array basically is a collection of similar things, of similar objects. So a multi-dimensional array is basically a collection of arrays. This array B here is a collection of one-dimensional arrays of 3 elements each. We have two one-dimensional arrays of 3 elements each. What I have tried to show in this figure is how array B will be organized in memory. I have assumed that the starting address of the array is 400. Each cell storing an integer here is a block of 4 bytes. As we know, each byte in computer's memory has an address. I am not drawing all the bytes, partition for all the bytes. I am drawing blocks of 4 bytes each, and that's why I'm writing only the starting address of each block. You can imagine a block of 4 bytes, something like this. The starting address is 400. Let's say each partition here is 1 byte. So the next byte has address 401, and the next one has address 402, and the next one has address 403. Overall, this first block of 12 bytes that contains these 3 integers 2, 3 and 6 that I'm showing in yellow here is my first one-dimensional array that I can call B0, and this next block of 12 bytes is my second one-dimensional array of 3 integers that I can call B1. So we have two one-dimensional arrays in our collection. We have two collections of 3 integers each in our collection, and everything is organized in one contiguous block of memory. Now let's look at this. B0 is from byte address 400 till 411. We have 3 integers and we have 4 bytes for each integer. The first integer that we can access as element at 0th index of B0 is taking 4 bytes, starting address 400. The next integer that can be accessed as B01, 1th element of B0, will take next 4 bytes starting 404, and the next one will be B02, element at index 2 of B0, and similarly we will have 4 bytes for 0th element of B1, 4 bytes for 1th element, and 4 bytes for element at index 2 of B1. As we had seen in our previous lesson, when we just use the array name, then it returns us a pointer to the first element of the array. Here B is a two-dimensional array. It is an array of one-dimensional arrays of size 3. So B will basically return us a pointer to one-dimensional array of 3 elements, pointer to one-dimensional array of 3 integers. In this statement I have declared a variable which is pointer to one-dimensional array of 3 integers, and the name of the variable is P. A statement like this is alright. A statement like this will not be alright, because B will not return a pointer to integer. B will return a pointer to one-dimensional array of 3 integers. Now I will write 3 print statements that I had also written in our previous lesson. I'm not writing the complete syntax for printf. Okay, so once again you need to tell me what will be the output if we would print these 3 expressions. We have P, asterisk B and B0. Well, for all these 3, output will be 400. Here when we say B, just using the array name B will return us a pointer to the first one-dimensional array in B. The type of a pointer variable is relevant only when we are trying to dereference or perform pointer arithmetic. But if we would just try to print the address stored in the pointer variable, it will be the starting address of the first byte of a block of memory. So if we have a pointer to this one-dimensional array that is storing 2, 3 and 6, then its address is 400. Now when we did an asterisk B, which is same as B0, we dereferenced, and now we have got the complete one-dimensional array B0. Now if I use B0, because B0 is a one-dimensional array, we will get a pointer to the first integer in B0. So we will get a pointer to B00, this block of 4 bytes starting address 400. Once again, if we would just print the address, then the starting address of this block is 400. That's why the output here is 400. Even if I would print ampersand B00, the output will be 400. B and asterisk B are both returning us pointers. The difference is that B is returning pointer to a one-dimensional array of 3 integers, while asterisk B is returning pointer to an integer. When we are just printing the address, both these objects, the complete one-dimensional array B0 and the first element in B0, have the same starting address, so the same starting address will be printed. The type of pointer plays role when you try to dereference or when you try to perform pointer arithmetic. We had also seen in our previous lesson that Bij can be written as asterisk of Bi plus j. If Bi for some value of I is a one-dimensional array, then Bi will give us an integer pointer, will return us an integer pointer to the first integer in Bi. Then adding j is basically performing pointer arithmetic and getting a pointer to integer at index j in one-dimensional array Bi. And then finally this dereferencing is getting the value of that integer. Once again, Bi can be written as asterisk B plus I. B is a pointer to one-dimensional array of 3 integers, so B plus I will also return us pointer to one-dimensional array of 3 integers, and dereferencing, this particular dereferencing, will give us the one-dimensional array, and the name of one-dimensional array returns us pointer to the first element in the array. So this once again will be pointer to integer. By now, if you clearly understand how all the pointer arithmetic and dereferencing is happening in these expressions, then it's not very difficult to understand how things will be for, say, a 3-dimensional array. Now let's say we have created a 3-dimensional array named C. We have an array of 3 cross 2 cross 2. A 3-dimensional array is basically an array or collection of 2-dimensional arrays. So if I have to show C in memory, I will show it something like this. I have assumed that the starting address of C is byte addressed 800. The first 16 bytes starting address 800 is my first 2-dimensional array. I am assuming that each integer will take 4 bytes. So all these cells in yellow are part of the first 2-dimensional array. The next block of 16 bytes starting address 816 is C1, and the next block of 16 bytes starting 832 is C2. We can further break down the 2-dimensional arrays into one-dimensional arrays. The first 2 integers in C0 are part of the first one-dimensional array C00, and 7 and 9 are part of C01. The first integer in C00 can be accessed as C000, and we can go on like this. Okay, once again we'll play the same game. I will write some print statements and you need to guess the output. This time just using the array name C will give us a pointer to a 2-dimensional array of integers of size 2 cross 2. So we can write a statement like this: I have declared a pointer to 2-dimensional array of integers of size 2 cross 2 here. The name of the pointer is P. If I would just print P or C here, and I'm not writing the complete printf statement once again, my output will be 800. Now if I will perform a dereferencing and try to print asterisk C, then this will be same as C0, and C0 is a 2-dimensional array, so we will get a pointer to the first element in C0. All these expressions are returning us pointer to one-dimensional array of integers of size 2, and the address printed will be 800. Remember, C is of type pointer to 2D array of 2 cross 2, and dereferencing once is giving us pointer to one-dimensional array of 2 integers. C is returning us pointer to 2-dimensional array of integers. C itself is an array, there is difference between the two types. Okay, for C, Cij, where I, J and K are some indices, can be written as asterisk of Cij plus K. And now once again we can write Cij as asterisk of Ci plus J, and the overall expression will look something like this. And we can go ahead and write Ci as asterisk of C plus I. If you are able to understand how I have derived these expressions, if you are able to understand all the pointer arithmetic and dereferencing in these expressions, then you are good working with multidimensional arrays using pointers. I want a quick answer for this one. What will be the output for this print statement? Well, C01 means we are going to this one-dimensional array that has these two elements 7 and 9, and when we are using the array name C01, we are getting a pointer to first integer in this one-dimensional array, pointer to this integer 7. Adding 1, we are doing pointer arithmetic to an integer pointer, so we will go to 9, and dereferencing will give us integer 9. In fact, this expression is same as C of 0, 1, 1. Now what will be the output for this print statement? Asterisk of C1 plus 1. C1 will return us a pointer to one-dimensional array, the first one-dimensional array in C1, this block containing integers 3 and 4. Adding 1 is performing pointer arithmetic and going to the next one-dimensional array. It's going to this one-dimensional array containing 6 and 1. And now dereferencing is basically getting the one-dimensional array from the pointer. And if you just use the name of the one-dimensional array, you get a pointer to the first element in one-dimensional array. So we will get a pointer to this integer 6. Output will be 824. This block of 4 bytes storing integer 3 is 816. Next will be 820, and next will be 824. We can try out these expressions in a real program. I'm writing this simple C program. I have created this three-dimensional array C. The data filled in is same as we were showing in the example. In the first printf statement, I'm trying to print C asterisk C, C0 and ampersand C00. All of these are pointers, and if I would just use %d, address would be printed. When I'm running this code, as you can see, the output for all these 4 expressions is same. Any guesses for what will be the output for this printf statement? This expression is nothing but C001. The output for first printf is different because this is a different run of the program, and in each run the assigned address would change. But whatever the address is, it will be same for these 4 expressions. I would recommend trying out all the different expressions that we were decoding earlier in a real program like this. Okay, the next thing that I want to talk about is passing multidimensional arrays as function arguments. I'm going to declare a function, and let's name this function func, and I want this function to accept a three-dimensional array as argument. So what do? If I wanted a one-dimensional array as argument, I could have given something like this. But as we had discussed in one of our previous lessons, this syntax is only a syntactical sugar. It is interpreted like this by the compiler. A fresh copy of array is not created for a function call. Only a reference to it in the form of a pointer is created. So now if in the main function I have an array, a one-dimensional array like this, and let's say the return type of this function is void, I can make a function call passing a like this, and this will be fine. Now let's say we declare a two-dimensional array of 2 cross 3, and now we want this function to take a two-dimensional array as argument. Now as we had discussed, a will return us pointer to integer, but b will return us a pointer to array of 3 integers, one-dimensional array of 3 integers for this particular definition of b. So for the function to take this array B as argument, definition should be something like this. The argument should be something like this. Either we can write this or we can write something like this. Only the first dimension can be left empty, the other dimension has to be specified. And now I can pass B. There is something interesting here. If I would declare a two-dimensional array something like this, let's say I declare a two-dimensional array x of 2 cross 4. Now I cannot pass x to the function because x will return pointer to one-dimensional array of 4 integers, while this function is supposed to receive one-dimensional array of 3 integers. If x is defined something like this, of dimension 5 cross 3, then passing x is fine. Now if we want to pass this three-dimensional array, then once again we need to see what pointer type C will return. So C will basically return a pointer to two-dimensional array of 2 cross 2. So we can either use a syntax like this or something like this, and then we can pass C. So this is how things will be for any multi-dimensional array. Except the first dimension, all other dimensions will be enforced. One common mistake that people do is, for a two-dimensional array they try to use pointer to pointer, something like this, and for a three-dimensional array they try to use something like this, which just won't work. So this is pretty much what we wanted to talk about pointers and multi-dimensional arrays. Thanks for watching.